Good morning to all of you. Good afternoon for the few people that are in a different time zone and they are already watching this webinar. Today, I'm going to lead this webinar for you. We call this webinar "How Will You Wire Up a Raccoon?" Okay, this is a webinar that it's been included inside a series of webinars that they took place during this year for different solutions in the SOLIDWORKS portfolio. You can see here the webinars that are already done and public. And today it's the electrical design, but in the future, as you can see, we're going to add even more solutions and webinars to this series. Okay. Again, this series of webinars are based on our cooperation with SOLIDWORKS customer Zero to Infinity. Okay, Zero to Infinity. I'm going to have a few words about Zero to Infinity. Zero to Infinity, it's a company, a Spanish company that is based near Barcelona, and they successfully launched its first rocket that they call Bloodstar from 25 kilometers above the sea level in the south of Spain, close to the city Cadiz, in the very south of Spain. And to give you an idea, these 25 kilometers, comparing that to a commercial airline plane, the top flight height of a commercial flight is 10 kilometers, 11 miles. Okay, so a little bit more than 11 kilometers. So the goal of this mission was not to put in orbit a rocket, and that was actually what happened, but was to test different communication systems on board for that mission. You can check and get more information from that customer Zero to Infinity from their website. You can Google it and you will see it. It's very easy. Okay, you can see a detail of that mission in different stages. It's basically the project from Zero to Infinity has 3 stages basically, and it's designed to put in orbit satellites up to 100 kilograms and volume about 2.5 cubic meters. The cost of that mission will be around 4 million, which is much cheaper than the cost of putting a satellite in orbit today. The difference from Bloodstar to a different company that it's in the same business is basically that the cost is reduced a lot from another competitors. And this mission at the first stage, the first phase, takes the rocket with that balloon that you can see on the top, and it's ascending to near space up to 20 kilometers, 25 kilometers, as you can see here, and that takes like 1 hour and a half, 2 hours, about that. And once this phase is complete, the flight starts and the rocket is released from the balloon. It has 13 engines that are that come to ignition at that moment, and for a few seconds, for a couple of minutes actually, that vehicle gets the altitude of 80 kilometers that you can see there on the top. Okay, so it's very quick also. And the ceiling of these kind of missions is to put in orbit satellites up to 600 kilometers of altitude, so it's pretty remarkable. Okay, now let's going to take a look at a movie from our customer that is going to explain way better than I do what's the mission and the concept of the company. Okay. Okay, I've just muted that because the sound doesn't go through the webinar presentation. So you can basically see here the description from the movie, but you can see the mission that we were talking about. Okay, how the first stage takes the rocket with the balloon into the near space, and then the rocket is released. Okay, and the ignition starts. Okay, so you can see that gets the altitude about 20 kilometers, 25 kilometers, and it gets to the position where the real mission starts, and that's 80 kilometers approximately. Okay, and then the satellite is released, as you can see here. Okay. This project has been completely developed with SOLIDWORKS, okay, and in that way it's been very easy to reuse that project to show you through a webinar like today the capabilities of our portfolio SOLIDWORKS tools, and you can see it's quite impressive. Okay. Again, it's the cost of putting a satellite in orbit today. It's astronomical compared to what Zero to Infinity with this project Broad Start it's giving today. Again, you may go to the website and you can see more details about that. Okay, I strongly suggest you to do that. It's very, very interesting. Okay. Okay, so sorry about that. The movie issue we had. So let's go back to the presentation. Okay, so this is the project, the rockoon. I think I haven't mentioned that before, but the rockoon, it's basically a balloon plus a rocket. Okay, that's where that comes from, and it has three different parts here. We have three different parts here. The top part is the balloons. You can see is the practically all the volume from this project. Then at the bottom we have the rocket, as you saw before. Okay, this rocket that you've seen in the movie just a moment ago, and in between the rocket and the balloon we have this platform. This platform is basically holding the two other parts together, obviously. And today we're going to use this part, the platform, to show you how SOLIDWORKS electrical, in this case, can help you create wiring systems inside a project. In order to do so, we're going to follow a logic sequence. I would say it's a logic sequence to generate this wiring, because it's the procedure that any company will follow in order to get where we're going to, which is the manufacturing of the wiring. Okay, so the first step will be to draw the circuits and create the connections point to point, pin to pin in SOLIDWORKS. Then the next step will be go into 3D, position the components, in this case the connectors, and connect them with wires. Okay. And last but not least, we are going to generate the manufacturing documents automatically. Okay, so that will be the sequence we're going to follow today, right? Okay, so once these three phases are defined, giving a name for each one of these steps, we get the three parts of our technical presentation. Over the next 20 minutes, I'm going to show you in detail the benefits for SOLIDWORKS Electrical, the benefits that SOLIDWORKS Electrical brings in terms of saving time and reduce the scrap material and improve the overall quality of the product. Okay. Right, so let's start with set the connectivity, okay? That's the first part, draw the circuits, basically. So let's take a look to it, and I'm going to SOLIDWORKS Electrical now for a second. And here in SOLIDWORKS Electrical, you can see that I'm going to start with these two connectors and 5 pins I have here, the connectors CN1 and CN2, connected with these wires in different colors, okay? The connector on the left hand side, CN1, has several pins. So when I insert connector, I have the option to keep inserting more connections for the connector I used before, like CN1, or create a new one. In this case, I'm going to do that, select an existing connector. From all the pins that that connector has available, I'm going to uncheck a few of them. So I don't want to insert all of them right now. I'm just going to insert a few. So I select them, I click on the screen, and all the pins are automatically inserted. Very easy, very quick. Okay. Now I go to insert connector again, and I'm going to select a different connector, not CN1 again, but CN3 in this case. Okay. Again, I get the same menu, and I'm clicking the spacebar right now, and I change the orientation for my connector. So now it looks in front of the other pins from CN1. So it's easier for me to draw the connections later. Now I'm going to select another connector, which is going to be CN1 again, because I have a few remaining connections there, okay? And I'm going to use all of them now, the 4 I got, okay? So here is placed. And last step is going to be for me, again, insert a new connector, which is going to be the number 4, and that will be in front of the CN1 remaining connections. Again, with the space bar, I change the orientation. I like to put that in front of the other pins, so it's going to be easier for me to draw the wires now. Draw the wires is very easy, but I can take those and copy and paste from the top the wires on the other connectors. I could also draw them like lines, but if I can copy and paste, it looks kind of, quicker. Now I'm going to add a table. Okay, that table is linked with my connector. In this case, CN2, now CN3, and now I'm going to insert a connector for CN4. Okay, which is going to be that one. This table is showing me information from that particular component. This is 100% customizable from the user. So the amount of information you can see here and the format could be changed in any way. Okay, but the good thing about that is that this table is constantly updated. Okay, so let's change a few things to see the changes automatically. I'm going to move these connectors down. So effectively, I'm changing the connections here. Now the pins are not connected to the same pins of the other connector. I just changed that. And I could also change the wires too. Draw a wire is like drawing a line in SOLIDWORKS. It's very easy. Okay, you just draw it, and if there is anything that you don't want to, just delete and it's gone. And all that goes to the database, and the database gives me back immediately the new connections. As you can see in the pin A from CN2, I got 2 connections now. Okay, everything is online, everything is constantly updated. Okay, very, very easy. And that's one of my favorites. If you like to edit your design, you just select from the drawing, and on the side panel at the right hand side, you can edit the configuration of any item or any selection of items. So you don't need to do like select something, right click, look for a specific command. No, you just select it and edit very quickly. Okay, very easy. That's really one of my favorites. And you can see all the changes have been automatically displayed in my table. So I don't need to do anything. My information, my tables will be always up to date, 100% sure. I don't need to worry about that. Okay, that's very, very, very useful. Okay, so when we set up the connectivity, we connect the pins together. We edit our circuit just selecting something and going to the side panel that's already open for me. What I get is the amount of time for designing the circuits, it's dramatically reduced, okay? I can design in much less time and much better because everything it's inside SolidWorks, and the database keeps the all tight and cohesive, if that word may apply here. So if I get into any mistake, software will let me know that I just did something wrong. Okay, so I just need to worry about drawing, and that's it. Okay. Yeah, I can see some questions already from the audience. What I'm going to do is answer. You feel free to send me any questions through the chat you have from the GoToMeeting menu, and I'm going to address those questions at the very end of it. Okay, but feel free to just send your questions right now. Okay, if you want to, no problem. Okay, now next, wire up in 3D. Okay, wire up in 3D. What I'm going to do now with the circuits I've created in 2 dimensions, what I'm going to do is to take those into the 3D space and connect them. Okay, so let's take a look at that. Okay, so now, still in 2D, what I'm trying to get in 3D, it's not separate wires. I would like to get all these wires together in a single route, let's say, okay, in a harness wiring. Okay, well, that's the word we use for that. Not separate wires, but all together in a harness wiring. Okay, so now if I go back, if I go to 3D, no back, let's take a look to the project. I go to the platform, and in this platform, I'm going to position my connectors. Some connectors are already there, and I could just click and zoom in, and I can see the connector. Okay, I'm going to do that again, and boom, automatically I know that my connector is already placed. From the left-hand side, you can see that CN3 is not checked. That means it's not placed yet. So what I can do, if the connector is there, I could associate, right-click, associate, and I select the connector from the assembly. And now that becomes the connector linked with my circuits in 2D. But if the connector is not there, I could insert rather than associate. And it's going to place my connector for my library of symbols in SolidWorks, of parts in SolidWorks. It's going to position the connector in any place that I need to. Now it's ready to be connected, everything. I click on route. There are no mistakes, that's good. And if I take a look to my connectors, you will see that I got actually the wires connected to them, okay, here. Okay, all the wires connected to the different pins, and they merge in a single point, as you can see here, because I want that so. I want that to become merged in a specific point and share the same route. That's effectively a harness. You can see also that each wire has its own color and size, and that comes from the 2D as well. Okay. Now you can see that in between 2 connectors, I got like a loop. I got like 2 different branches. Okay, that's correct according to my rules in SolidWorks, because SolidWorks is looking for the shortest path available, so that's fine. But probably is not good for manufacturing. So I'm going to, and you can see now those red lines here. I'm going to take a part of the geometry of my project, and I'm going to ask SolidWorks to ignore that in order to route new wires. So what I'm going to do is to select a few lines here that you can see in red color. Okay, it's easier to do that than actually select the geometry, okay, itself. But I'm doing that, and now SolidWorks is going to ignore this part of the geometry for wiring. So still we'll look for the shortest path available, but ignoring that part of the design. So I'm going to route again because the rules change. And hopefully, yeah, there's no errors. That's good. And now my wires have changed. Okay, they must change because I've changed the rules. So now if I hide the geometry, you can see that now in between those two connectors in front, there is no connection anymore. There is no loop anymore. Now my wires are not just disappear, they took a different path. So they go all around my project to connect these connectors again. They don't disappear, they just selected a new path, okay? But always looking for the shortest path available and for the rules I'm setting. We call these rules the segregation option, okay? In that way, I may take this geometry and say, okay, ignore that and take the other one, okay? All right, so we've seen the wiring up in 3D. That has huge impact in any project. But I would say, if I need to say just one benefit from that, I would say that the main benefit is to reduce the amount of scrap material. Doing this, you don't need to go downstairs and take the distance yourself to see the amount of wire you're going to use, or you don't need to oversize the amount of wire just in case isn't too short, okay? You need to consider that this harness wiring sometimes are expensive. So you really want to be sure the first time that your design is correct, okay? So you save a lot of scrap material. When I talk to our customers and I ask them to tell me one benefit, only one benefit, the main one that you have from SOLIDWORKS, without any shadow of a doubt, they take this one. The amount of scrap material I'm saving, the amount of money I'm saving from using, not using a 3D integration, okay? Okay, so now the last step is going to be to generate the manufacturing document. So I got my design, I got in 3D, all connected with connectors, and now I need to generate the proper documentation to manufacture that, okay? I will probably send that to another company to manufacture it, probably another country, okay? So I need to be sure that the documentation is good, okay? Any mistake on that has an impact, a direct impact in money, okay? So let's take a look to that. Okay, now, so taking again the harness drawing that I just created in 3D, inside SOLIDWORKS we have the option to flatten a route. That means that it's going to take the wires and put that in a 2D space, in a flatten, okay? So in that way I could print that in PDF, for instance, or any other format, okay? So I select that option, I get the preview, I could change that preview, move the connectors around if I want to, but that looks good to me, so I'm going to keep that one. This flatten is not to a scale, but you may choose the option to be on scale. That's up to you. I prefer that because it's better for the webinar. And now I'm going to move those tables around, okay, to be more sexy, let's say. And these tools are generated automatically, and you can see it's showing the information. Here it's information from the connector, each pin, the color of the wire that's connected to it, and the wire name, okay, displayed as well. So I know which wire I need to connect to which pin. Then I got the bill of materials down at the bottom, and it's linked with the balloons you can see from the flattened route on the top. So each part has the quantity or the length if we talk about wires. And that one is the pin-to-pin information. So I get for each wire, source, destination, and length for each individual wire. I generate that just with a single click, as you saw. And I'm 100% sure that this is always up to date. If I change anything in my design in 3D, that will be reflected here because this is a drawing, a SOLIDWORKS drawing. And if I change something in the 2D design in the circuit, that will also affect the 3D and therefore will affect my document here, my drawing, okay? So everything is connected. So what SOLIDWORKS is really giving to the customer, it's not just integrate 2D and 3D, integrate electronics on mechanical. it's doing that without any import or export system anymore. Okay, no manual procedure in the middle. You just keep working and everything will become updated and up to date. All the tables, all the information. Okay. All right, so that was generating the manufacturing documents for this harness that we just created. And I would say that probably the main benefit for that is that all the documentation, it will be always up to date. So you don't need to worry about that anymore. Okay. If you export and import and you use some intermediate formats, you may forget. You may forget to update the latest information. That's not happening with SOLIDWORKS anymore. Okay. All right. So wrapping up all the presentation today, we went through these 3 steps. Set connectivity first in the 2D, then wire up in 3D the connectors, and generate the manufacturing documents. And some of the benefits that I show you was that you will be able to reduce the amount of time that you need to create your designs. You will save money through the amount of tests, prototypes, scrap material that you're using today, you go through today, and always you will get consistent information from your documents, which is really a must these days if we need to reduce the amount of time dedicated to our projects. Okay, so again, just remember that that was all based again in our customer 0 to Infinity. Thanks them for the cooperation through these webinars, and remember that we went through some webinars already, and there are still a few to come that we will publish in the next weeks. Okay. All right. So yeah, like I said, if you have any questions, any other questions, please drop an email either to myself, Javier Gonzalez, you can see here, or my colleague, Moataz, which is the technical manager for Middle East. Okay. Or contact your local reseller for more information about electrical or any other solution in our portfolio. Okay. So yeah, that was it. So thanks very much again for your time in this webinar, this quick webinar. I hope that that was useful for you, and we will keep you posted on the next webinars. We will deliver to you in the next weeks. Okay. Thanks very much again. Have a good day. Bye-bye.